Let's solve this primal problem with maximization simplex algorithm, and also eventually we will get the solution for the dual problem as well. So let's first make the Tucker tableau. So this is a primal table and this is our dual table. So the values are all the same. So these values are all the same. The only difference is in the labeling. So here on the top we have x1, x2, and -1, and these are our slack variables. And here the labeling is on the left hand side, y1, y2, and y3, and the slack variables are at the bottom, s1 and s2. So we will go about solving the primal problem using simplex algorithm, and eventually we will be able to get the solution for this table as well, only by solving one table. So let's solve it. So because these both are positives, so we can choose any j column. So I'll be choosing this first one. So by using the minimum ratio, this will give us the minimum ratio 25/2. So 2 will be my pivot. And the process we used in the previous video, same will be used here to find the next tableau. So this is the tableau we got after our first iteration. Now we still have a positive here, so we have to choose another pivot by the minimum ratio. So this will be our next pivot, and we'll do the same process. So now we have all negatives in the last row, so means we have reached the optimal solution. So we can say, okay, the optimal solution for the primal problem, x1 and x2 is 10 and 5 respectively, and t1, t2, and t3 are all zeros. Now for the dual problem, we will just switch the labels, so we will use the same table. We will just copy the values of the same table. So on the left hand side it will be y1, s2, and s1, and this will be the -1 column, and here we'll have y3 and y2 and the function g. So how do I get these s1 and s2? So if we refer back to our first pivot, so our first pivot 2 was in the first column. Now if we refer to the dual tableau, the first column corresponds to the slack variable s1. That's why we have s1 for this row. Now for s2, the second pivot we chose was 1, which was in the second column. And in the dual tableau, the second column corresponds to s2. That's why we have s2 here. And we just swap the places of s1 and y3 like this, s1 and y3, then s2 and y2. So the final values for the dual tableau is s1 and s2 is equal to 0, 0 because these are the slack variables. And the main variables y1, y2, and y3 are, so y1 is 0, and y3 and y2 are 1, as we can see here. These values are for y2 and y3. So just by solving the primal tableau using simplex algorithm, we can also solve the dual problem.